Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 10 from the May-June 2022 Cambridge Paper 3 Variant 1. This is from the 9709 syllabus. And this is question number 10A. I'm going to save as a separate video and the rest of it as separate videos because A is basically about differentiation. And the rest of the question is concerning what's called iteration. So I'll save them as separate videos so I can save them under different topic playlists. Anyhow, the first question, it says the curve y equals x times root sine x has one stationary point in the interval of x between 0 and pi, where x equals a, as we can see in the diagram. Show that tan a equals negative a half a. So the stationary point, which is the key word here, is a point of zero gradient, which we can see is where x equals a. So at the stationary point, we know that the gradient of the graph is equal to 0. So our objective here is to find the gradient of this graph. That's what we need to do. Okay, so that's what we're going to focus on, to differentiate this function. So we have y equals x times sine x. I'm going to write this as sine x to the power of a half, just to get it ready for differentiation. So here we have a product of two separate functions. I have to differentiate this by using what's called the product rule. So I'm going to choose one of them as u and the other one as v. It really doesn't matter which one you do. So I'll call u x and v will be sine x to the power of a half. So when I differentiate u, I get 1. When I differentiate v, I'm going to get a half times sine x to the power of negative a half. Then I have to multiply by the differential of sine x, which is cosine x. This is using the chain rule. Okay, so if I just rewrite this in a more friendly kind of way, this is going to be basically cosine x over, and you'll have 2 times sine x to the power of a half, which is the same as 2 times root sine x. Okay, so now when I write the product rule, I like always to do it this way. So v times u dash, so that's going to be sine x to the power of a half, which is basically the square root of sine x. So this is dy dx. dy dx equals the square root of sine x plus I have x times the square root of, so not square root, x times cosine x over x times cosine x over 2 times the square root of sine x. Okay, so that gives us that. So now they told us when x equals a, there's a stationary point. So basically, when x equals a, the stationary point is where the gradient is 0. So when x equals a, dy dx is equal to 0. So I'm going to put these values in the equation we formed. So I'm going to replace the dy dx with 0 and the x with a. So I have the square root of the sine of a plus a times the cosine of a over 2 times the square root of sine of a. We know that's equal to 0. Now I have to solve this and I have to show tan a equals minus a half a. So I have to end up with a tan here. So the first thing I'll do is I'll multiply both sides by 2 times the square root of sine a to get rid of the fraction. If I multiply this by 2 times the square root of sine a, I'm going to get 2 times sine a, because root a times root a, the root a will cancel out. And if I multiply this term by 2 times root sine a, I'm going to get rid of that term. So I'll end up with a times cosine a equals 0. Multiply this side by 2 root sine a, I'm going to stay 0. 0 times anything will stay 0. Now I'm getting somewhere. I can divide both sides by cosine a to get rid of, or to turn this into tan a. So this becomes 2 times tan a plus a equals 0. So 2 times tan a is equal to negative a. So tan of a is equal to negative a over 2. So we can say the tan of a is equal to negative a half of a as required for us to show. Okay, tan of a equals negative half a. So that completes question 10 part A. Now this is all to do with what's called the product rule, which was dealing with differentiation. And part B, C, and so on, they go on to another topic of iteration. So I'm going to stop here, and I'm going to save the other videos in a separate, the other parts of this question in a separate video, which I can save under the topic of iteration. So you'll find that this video, you can, if you click on the playlist that will appear here, it will take you to the playlist which contains other questions from this particular paper. Okay, the May, June 2020, paper 3, variant 1. And if you click on the playlist over here, it will take you to the playlist dealing with the topic of differentiation, and specifically the product rule and the product and quotient rules. You'll see a playlist here dealing with that topic, and the differentiation in general topic you'll find over here from P3. And you can subscribe to my channel by clicking on the link that you'll find at the top. Thank you for watching, and see you soon.